Okay, let's unpack this. What if everything you thought you knew about the fundamental building blocks of reality shape, structure, even intelligence wasn't quite the full story? What if it was just, a shadow, a projected outline of something far deeper, something more dynamic? Today, we're embarking on a truly mind-bending deep dive. We're exploring a concept that could really shift how you see the world. It's based on an essay, Geometry is the Shadow of Coherence, a companion essay on topological intelligence, structural emergence, by Philip Lilien. Our mission really is to explore how geometry, from the tiniest particles right up to the cosmos, might not be the origin of structure, but maybe it's a result instead, a visible imprint of something the essay calls coherence and topological intelligence. It's pretty abstract stuff, definitely deep territory, but we're going to try and make it accessible. Hopefully spark some genuine aha moments for you.
Yeah, what's really fascinating here is how this essay just completely reframes our understanding of how forms actually emerge. It's arguing that geometry is basically the visible echo. It's the leftover imprint of these deeper coherence fields, this sort of inherent topological intelligence. It's kind of like discovering the blueprint for reality isn't static lines and angles, but something much more fluid, more energetic, maybe even intelligent.
Okay, so let's dive right into that core premise then. Geometry isn't the origin, it's the echo, the shadow, this idea of coherence before geometry.
Yeah.
That's a big conceptual jump. How do we even start to wrap our minds around what a coherence field actually is, and what does it mean for geometry to just be a result?
Right. Well, think of a coherence field as maybe a unified medium, like a vast dynamic ocean of potential. But instead of water, it's filled with pure energy, information, possibility. And within this field, certain resonant alignments, like waves lining up, can stabilize. They become persistent patterns. Geometry, then, isn't the field itself, but those stable patterns that become, well, visible to us. It happens when those alignments hit certain thresholds. The essay calls them topological thresholds, allowing them to be seen, measured, and to interact energetically. So it's really this dynamic field of energy relationships, phase relationships, symmetries that generates the possibility for structure in the first place.
Okay, so if I'm getting this, it's like we're seeing a 2D shadow, but the actual thing casting it is this much richer, higher dimensional coherence field. The essay uses that analogy, doesn't it? Just as a shadow reveals the outline of a high-dimensional object, geometry reveals the dimensional resolution of coherence.
Yeah.
It even calls geometry projection, coherence field tensor. That's a huge shift from thinking of geometry as fundamental.
It absolutely is a massive shift. And it forces the question, if geometry isn't the base layer, what is? It moves our focus from, static shapes to the dynamic forces and relationships underneath those shapes. It's foundational.
So if geometry is the shadow, the essay then brings in topology. It argues topology is the sort of hidden fabric allowing coherence to stick around, to persist. And this isn't about measurement, like length or angle, but relationships that hold even if things get stretched or squashed. How does topology manage that? How does it bring stability?
That's a great question. Topology provides the underlying rules for how coherence can maintain its integrity, its structure, even when things change. Look at graphene, for instance. Its amazing conductivity, near zero loss. That's not just its nice hexagonal geometry, it's the topological coherence underneath. The electrons stay phase-locked in a continuous flow. Geometry is the outcome, topology is the reason it works so well. And even something like quantum entanglement, you could describe that as a topological bond.
Linking particles across space.
Exactly. Linked by shared coherence, maintaining that link no matter the distance. Not physical closeness, but topological connectedness.
Okay, moving from physics to biology then, how does this apply to life? The essay talks about biological forms as topological resonators, things like mitochondrial folds, DNA.
Right, and this is where it gets really insightful for understanding life. These complex biological shapes, they aren't just random geometry, they are essentially topological solutions. Solutions to the energy problems life has to solve. Evolution selects for coherence patterns that are stable and efficient. The geometry we see in a mitochondrion's folds or a DNA helix, that geometry is just the physical form that captures an optimal topological setup for energy transfer or information storage. It's all about maintaining continuity and efficiency. Geometry freezes that efficiency into an observable shape.
The essay then grounds this with some really concrete examples, right? Showing this geometry as coherence, shadow idea, playing out in all sorts of systems.
Yes, exactly. And they're quite diverse. Think about modern batteries, those fractal electrodes. Their complex geometry isn't just for show. It's specifically designed for coherence-efficient charge distribution, maximizing surface area and flow topologically.
Okay.
Or in quantum materials, you have topological insulators. They show phase locking because of these entangled topological invariants. It protects the quantum state.
Wow.
Even photosynthesis. The way those protein complexes fold isn't arbitrary. It enables energy to transfer like a wave using quantum coherence. And closer to home, our own neural circuits, their branching structures, the recursion. It optimizes the coherence of energy and information flow.
So even down to DNA computing.
Right. Using helices, knots, folds, not just as structures, but as ways to create spatial resonance logic through field entanglement. It's geometry serving a deeper coherent purpose.
So, okay, every shape, every structure, it's not just there. It's like a memory or record of the most efficient way energy organized itself. The essay puts it strongly. Geometry is ontological memory, and form is the echo of efficiency. What does that actually mean for a shape to remember something?
Exactly. It means you should look at every shape, a spiral nebula, a snowflake, a crystal lattice, not just as a static form, but as a kind of fossilized record, a record of how energy found the most efficient way to arrange itself. A spiral, for instance, isn't just a curve. It efficiently stores angular coherence. It's an optimal path.
Like water going down a drain.
Sort of, yes. Or a fractal pattern, it conserves coherence across different scales. A lattice minimizes interference between fields. Geometry, in this view, preserves the memory of that optimal energy flow, like fossilized tracks. It gives us the structure, the inertia, but the intelligence, the dynamic part, was in the field that shaped it.
Right. And this leads to maybe the most mind-bending part. The essay suggests intelligence is geometric rewriting of coherence. It's saying geometry isn't just random fallout. Systems select it intelligently. For efficiency, how does that work? Is it conscious selection?
Well, maybe not conscious in the human sense, but intelligent in terms of optimization. Nature isn't just building randomly, it's finding the best, most coherent solutions. Organisms evolve structures, yes, but not just for looks. They evolve them to maximize coherence for function. Think about those spirals again, pine cones, galaxies, DNA. Why are they so common? The essay argues it's because they optimize phase relationships, they conserve energy gradients, they're incredibly efficient designs.
Nature's algorithm finding the best shape.
Kind of, yeah, finding the most coherent and efficient forms over and over.
But what about the brain? The source mentions neural gyrification, those folds. How do they fit this intelligent geometry idea?
The brain folds, the gyrification, it's not just about cramming more surface area in. The essay suggests they arise through a recursive coherent process. Cortical zones resonating together. The brain is literally structuring itself, folding itself to optimize the flow of information and energy. It uses its geometry to store information and energy, but the actual processing, the thinking, happens through these dynamic coherence phase maps.
So intelligence is?
The essay defines it as the coherence operator selecting geometry as a form of efficient phase storage. The brain's ability to shape itself physically to better handle coherent processing.
And it's dynamic, too. Intelligence rewrites geometry across time. It's not fixed.
Precisely. Think about neuroplasticity. When we learn, our brain physically changes. That's a perfect example of temporal coherence rewriting geometry.
Okay.
Cellular memory is another angle, even embryogenesis, how an organism forms. Those morphogenetic fields guiding development, they're like coherence fields resolving into cellular arrangements over time. The geometry of an organ emerges from the dynamics of the field. It's constantly adapting.
So, if this whole framework holds water geometry as coherence is shadow, what does that mean for us, for designing things, for engineering? The essay says we have to start designing at the level of coherence, not just geometry. What does that look like?
That's the crucial takeaway for the future, I think. Look at quantum computers, they fail without maintaining topological coherence. That's the bottleneck. Brains work because of coherence modulation, not just the wiring diagram. Even stars forging elements rely on coherence field cascades, not just heat and pressure.
So we need a new approach.
We do. If we want truly advanced systems, we can't just focus on the shape, the blueprint. We need to understand and manipulate the underlying resonance, the field dynamics, design with coherence in mind.
Which brings us to coherentputers. That sounds pure sci-fi. What are they supposed to be?
It does sound futuristic, doesn't it? But the concept follows logically. Coherentputers wouldn't be based on fixed circuits. They'd be devices that directly process and manipulate coherence fields themselves. Imagine computing happening within dynamic resonance lattices. Information wouldn't be just zeros and ones in silicon, but patterns of energetic alignment. Geometry would only emerge as an output if needed.
Like a liquid computer.
In a sense, the essay calls them topological intelligence matrices. Their logic is based on the flexible, invariant rules of topology and coherence, not rigid geometric gates, a fundamentally different way to process information.
And this isn't just limited to tech, is it? The essay goes big, proposing a coherence-centric cosmology, saying even space-time isn't fundamentally geometric.
Right, it takes the idea all the way up. It challenges our deepest assumptions about the universe. In this model, gravity isn't quite a force, it's more like an asymmetry in the coherence field. Denser regions, less uniform regions. Mass isn't fundamental stuff, but a concentration of coherence. And space itself, the emptiness, is what appears when coherence reduces through topological expansion.
So the geometry we see in cosmology
Is just an illusionary cross-section, according to this view, a snapshot of this vast, dynamic, coherence-driven universe.
Wow. And finally, it touches on the observer. Geometry as a residual signature of observer function. Our role in shaping reality.
Yeah, it connects to those ideas from quantum mechanics. It suggests that when we measure, we aren't just passively observing geometry, we're actively participating. The act of observation causes a kind of symmetry reduction, collapsing the possibilities within the coherence field into a specific geometric form that we perceive.
So geometry is the trace left by our interaction.
Kind of like the footprint of the observer interacting with the underlying field. It puts consciousness, or at least observation, right at the heart of how reality manifests geometrically. It's a profound implication. So if we try to pull all these threads together, geometry is what coherence leaves behind. It's a trace, a shadow, a signature. It's the memory of coherence, the physical scaffold built by field intelligence, and maybe even the signature of our own observation. The bottom line, we need to shift our thinking from designing by shape to designing by resonance.
So what does this mean for you listening right now? Well, it means maybe looking at every shape, every structure around you differently, with completely new eyes, from the intricate folds in your own brain, or a seashell on the beach, or the grand spiral arms of a galaxy. Ask yourself, is this just a shape? Or is it maybe the frozen echo of a deeper intelligence, a memory captured in form, a memory of how coherence once moved? Because, as the essay concludes, and it's a powerful thought, coherence is the language of the universe, and geometry is its accent. Quote, what might you discover when you really start listening for that accent in the world around you?